For today's video, we are going to talk about simplifying fractions. And if you're thinking to yourself, oh, I already know how to simplify fractions, I can skip this video. We are going to be adding some extra stuff to these, including with variable expressions. So hang in there. Our learning target today is I can simplify fractions with variable expressions. Write down what you already know about simplifying fractions. So I'm sure you already know how to simplify fractions that just include numbers. So write that. Write the date you're watching this so you can keep track. And then we have no vocabulary today. So at this point, please pause the video, writing down all of this, and when you're ready, restart it again. So when we think of simplifying fractions, what we usually think of first is just simplifying a regular fraction. So this might be a number that says, write in simplest form. For example, maybe you would have 18 over 45. To simplify this fraction, I want to find a number that goes into both the top and the bottom. So if I think of what is the number that goes into both the top and the first number that comes to mind for me is the number 9. So to simplify, I'm just going to divide by the number 9 on both the top and the bottom. 18 divided by 9 is 2. 45 divided by 9 is 5. Now I have a simplified fraction. Okay? Now I could have said, oh, maybe I thought of 3 there. And I simplified by 3. Well, if I simplified by 3, I would have gotten 6 over 15. And I still would have needed to simplify again by 3 to get 2 over 5. So if you don't think of the biggest number right away to simplify by, that's okay. You're just going to have to keep simplifying until you get there. The same way I can simplify 36 over 84. Now, maybe when you see this, the first thing you think of is, I'm going to simplify by 2. That's going to work. You could simplify by 4. You could simplify by 6. There's lots of things you could simplify by here. The one that actually works the best is 12. Both of these numbers are divisible by 12. 36 divided by 12 is 3. 84 divided by 12 is 7. And we get 3 sevens. Again, I could have started by simplifying by 2, and then by 2 again, and then by 3, or started by simplifying by 3, or started by simplifying by 4. All of those things are going to work. But it's easiest if we find the biggest number possible. However, that's not really the point. This is just a quick review. What we actually want to be able to do is simplify fractions that have variable expressions. And that looks like this. 3x over 12xy. So this is a fraction that has variables in it. We have x's and we have y's. If we want to simplify this, we want to divide out things that are the same on the top and on the bottom. One of the great things about this is that when we're simplifying, we're going to be able to see things that work together. So here, if I have 3x on the top and 12 times x times y on the bottom, here I see right away that I have an x and an x. What that means is that I can divide by x on both the top and the bottom, and these x's are then just going to cancel out. That leaves me with just a 3 on the top and 12y on the bottom. I can simplify again, however. Now that I've divided out an x from the top and the bottom, I see that 3 and 12 are also both divisible by 3. So I'll do 3 divided by 3, which is 1. 12 divided by 3 is 4. And I still have the y. And so my answer to simplifying this is 1 over 4y. We've done simplifying equations before, but this is the first time we're going to be simplifying with x's and y's and variables involved, okay? But it's the same exact thing as when we do it with just numbers. We're going to find things that are in common on the top and bottom, and as long as we can take it out from both the top and the bottom, it's still equivalent. For my next one, we're going to do 3x over x to the third power. Now to simplify this, I have to remember what x to the third power means. I know that 5 to the third power, well, that would equal 5 times 5 times 5. So x to the third power, that means that it's actually x times x times x. So the first thing I want to do to simplify this is I want to rewrite this. 3x on top, and on the bottom, instead of x to the third power, I'm going to write x times x times x. Now that I've done that, I can see what I can cancel out. Well, I have an x and an x right here. That means I can divide by x on both the top and the bottom. And all I'm left with on the top is a 3. On the bottom, I'm left with 2 x's. That means that my simplified answer is 3 over x to the second power. Okay? I want to do a few more of these so you can see some of the different things that can happen here. So for my next one, we're going to do 2y squared 5y. And this is negative. So the first thing to know is that having a negative sign in front of it isn't going to change anything. Always the first thing I like to do with these is rewrite the exponents as just multiplication. That means on the top I'll have 2 times y times y, because y squared is y times y. And on the bottom, I still just have 5y. And this negative sign is coming along for the ride. It's hanging out. Well, here I see that I can divide out 1y from both the top and the bottom, leaving with negative 2y over 5. So you can see that adding the negative didn't really change anything else in the whole problem. Now, these can get pretty complicated, and it will be up to you to make sure that no matter how complicated it gets, that you show your work carefully, and make sure you know what you're doing. So let's say we had, for example, 35x y squared over 7x squared y to the fourth. This has gotten a little bit complicated, so let's write it out without the exponents. On the top, I have 35 times x, and then y squared means I have 2 y's. That's the top. On the bottom, I have 7 times x squared is x times x. Y to the fourth means I have 4 y's. Now I can start figuring out what I can actually get rid of. I see I have an x and an x, so I'll be able to divide by an x on both the top and the bottom. I see here I have y and y, so I'll be able to divide out a y. And I have another pair of y's. Now my other 2 y's that are on the bottom and the other x on the bottom, those can't cancel out because they don't have another on the top. Remember, anything that I change on the bottom, I also have to change on the top fractions. By itself on the top. And in the bottom, I have 7. I still have 1x, and I have 2 y's. Okay? However, I see that 35 and 7 can also be simplified. Both of these numbers are divisible by 7. 35 divided by 7 is 5. 7 divided by 7 is 1. I have x, and I have 2 y's. So my final answer is just 5 on the top. On the bottom, I have 1. Well, I don't really need the 1. I could leave it, but I don't need the 1 because 1 times anything itself. And then I have x, and I have 2 y's, so y squared. The answer is 5 over x times y squared. Again, this is a little bit complicated, and the only way to work it out is to write everything out really, really carefully and then cancel out what can be taken from both the top and the bottom. This leads us to the last type of thing we might be asked to do, which would be to tell whether two expressions are equivalent. So let's say you were asked if 4ABC over 5AB, if that was the same as 4C over 5A. To determine if these are equivalent, we're going to simplify them, which is just like what we were doing above. So if I want to simplify these, I'm going to start with 4ABC over 5AB. I see that I have an A and an A that can be canceled out. I also have a B and a B that can be canceled out. So if I divide out the A and the B, I'm left with just 4 and C on the top and 5 on the bottom. For 4C over 5A, if I'm looking for something I can cancel out on both the top and the bottom, well, C and A can't cancel out. Those are different letters. And 4 and 5, you can't divide by anything the same. So that means 4C over 5A is already as simplified as it's going to be. So now I want to look at these and say, are these two things the same? And the answer is that no, they are not. So to tell whether things are equivalent, all I'm doing is I'm saying, okay, let's simplify these, see if they're the same. If they're the same, then they're equivalent. And if they're not, and so they are in this case, then the answer is no, they are not equivalent. As always, please feel free to rewatch any parts of this video you need and let me know if you have any questions. Have a great day.